Hi guys, in the previous video on k-means algorithm, we had discussed about scatter plot and how various parameters related to scatter plot work. In this video, we will be seeing how we can calculate the distance between two data points. So let us switch to OneNote. So we have this plot with these two data points, A and C. We have to find out the distance between A and C. To do so, we will be using Euclidean distance formula. And this is what the formula is. So let us put the numbers into this formula. And before we do that, let us call this as x2 and this as x1 and this as y1 and this as y2. So x2 is what? 5, x1 is 2, and y2 is 3, and y1 is 1. Maybe we can give a matching color over here. This 5 comes here, 2, then y2 3, and y1 1. Okay, let us solve this. This will give us 3.605 around that figure. So here we have found out and the distance being around 3.605. And this formula, this Euclidean distance formula is basically based on Pythagoras theorem, which says that AC square is equal to AB square plus BC square, correct? We can also write this as AC is equal to square root of AB square plus BC square. This knowledge of finding distance is going to be handy in k-means algorithm. Okay, now we have seen how we can calculate the distance between two data points. So we will do the same stuff on Jupyter Notebook. We are importing these libraries and we are creating a data frame having these values, right? Same coordinates. And we have drawn the chart which we considered on OneNote. Here, look at this data frame. There are two records and there are two columns. So basically they are X and Y coordinates. So let us do the calculation. First, we will deal with X axis and then Y axis. So let us get the data. How we can get it? We will say df log. See, Y is here. Y is here and X is here. How we can deal with this now? We have to say log. If we were to bring 5, then we will say 1 and then we will say X minus df log We have to talk about this 2. We have to get this 2 from x-axis only. So what we'll say? 0 and x. And mind you, this order doesn't really matter. We can as well write this. Here I will write 0 and 1. Why? Because we are squaring it, right? So that is not going to give us different result. It is going to be the same result. Just see. I run this, I run this. So order doesn't matter. Okay, fine. Let us move on. Plus, this is x is done. Now let us talk about y. So we know very well, since order doesn't matter, simply we will write 0 y and plus df log, sorry, it should be minus df log 1 y. Okay. So here we have to put this whole thing into in parenthesis and square it. Good. Now square root. See, we should get the same figure 3.6055, etc. So we are getting that. Good. Now what we can do is, okay, this is very wordy, right? We are writing so many things to get it. Can we simply plug in the number, raw number, and see whether our formula is working or not? Okay, we can do that. So what we are considering, log 1 x. What is that? Log 1 x. That is 5 minus, what is log 0 x? Log 0 x is 2. Okay, right here. Squared it. Now come here. Then log 0 y. What is log 0 y? 3. Correct? Directly write 3. Okay. Oh, it has gone to the comment mode. Okay. Now 3 and then log 1 y 1. We will square this also. Having done this, next thing is what? Bringing in square root function. Square root function. We're getting this value. So we are happy. So we have learned how to calculate, and we will use this learning while working on K-means algorithm. Fine. Okay. Now you may ask, okay, this is all about 2D data, two-dimensional data. What about 3D? It's very simple. If for 2D it is going to be like this, right? Minus. For 3D, it is going to be like this. And of course, everywhere as per formula, we will do this to take care of negative numbers. And then the whole thing is what? So this is how it will work for 3D. This is how it is going to work for 4D also. The moment we are dealing with 4D, we will put another dimension into this formula. That's all. So see, we have discussed about Euclidean distance formula. There are other formulas as well. We have Manhattan and others. We will discuss about them in future, but right now we will use Euclidean method only. Okay. Now, this is the shape of data points, right? We can have data point shape anything, right? I mean, we can have, it is going in different direction, right? We can have this, or irrespective of direction, we will be able to calculate the distance by, creating a 90-degree triangle or right angled triangle like this. So here we are making triangle, 90-degree triangle. Here also we could make. So irrespective of direction where exactly it is, we can make, and we can use Euclidean distance formula because basically it is based on Pythagoras theorem. Fine. Now let us move on to a simple task. With whatever knowledge we have acquired about scatter plot and calculation of distance, we are going to perform this task. This task has no objective other than getting used to things like how to draw a scatter plot, how to calculate distance, and maybe how to calculate average of few data points. And once we can do this, we will be ready to deal with the things pertaining to K-means algorithm. Okay, so let us complete this task quickly. Generate data for X and Y coordinates. How we can do that? We will write something like this. Random rand int. Generate few numbers. Maybe we will have, okay, 25. Y np random int 25 numbers. Okay, good. So X, Y we have generated, and these will be random numbers, right? Just see X and Y. And one more thing, if you want to repeat the same set of numbers, we can write something like this, random seed 1. Now look, if it generates this set of numbers, see 6, 9, 10. Again I go, though it is randomly generating, but it will keep repeating so long as the seed is 1. Okay, good. Now let us create a data frame out of it. That is point number 2, create a data frame. So how we'll do that? PD data frame list zip xy, and then columns is equal to X and Y. So this is working? Yes, it is working. So let us name it as DF. So our data frame is ready. We can have a look at it. Okay, done. Point number 2 is taken care of. Consider any of the data points as a centroid. 3. What does it mean? It means that you take one particular coordinate and consider it as a centroid. Centroid is basically a center location of a given cluster. So just we are considering, it will not be center, but we are just considering initially. Okay. So what we will do? We will name it as centroid only, and we will take any of these coordinates, maybe row 0, this index 0, 1, 2, 3, anything. So let us take the very first one. Now just see how it looks. It looks something like this. Good. 6 and 10 have come here. Fine. So that is done. 4. Draw a scatter plot for both the data points as well as the centroid. Okay, we will do that. How will do that? We know PLT scatter dfx dfy. Run it. This is a scatter plot about data frame, all the data points. We also have another stuff called centroid. So we will do what? For this PLT scatter and centroid, X and centroid Y. This is what we are calling it as centroid, though it is not at the center location. Okay, that is fine. Let us not worry about that right now. We will write PLT show, PLT show, so that this doesn't come here. Okay, fine. Let us increase the size of this. Size, we can make it 200. Marker, maybe we can make it star. So this is how it looks. Good. Now, point number 4 is done. Point number 5, calculate the distance between this centroid and each of the data points. So now, what is going to happen? We considered earlier only 2 data points. And look here, we have so many data points. But what the question is asking us, what this task is expecting us to do, it is telling that you start calculating distance between this data point and this data point, this data point, this, and make no mistake, my centroid is sitting on top of one data point, isn't it? One of the data points is lying here just below this star. We are able to see only star. Why is it so? Look, we have created this centroid out of the very first record, the very first coordinate. So this first coordinate is what? 610. So when we are saying dfx, dfy, so that 610 will be there, right? And on top of that, the centroid is sitting. So to see that, let us comment this. This is how it is. And remove the comment. This is how it is. Still better. Let us run twice. One without star and again with star. See, this is your data point. We created centroid out of this data point and we are telling scatter plot to show us both. So the overlapping is taking place. So we are seeing star. This is one of the data point. So what will happen is, the point that needs to be noted is, we are going to calculate distance between each and every data point with this centroid. And the data point which is there right there with star, we will calculate distance for that also. We will get 0 distance. So let us write like this: centroid log 0 and x, enter it. The calculation is taking place. Nonetheless, we have to take care of certain things. What we will do? Put this parentheses and square. Good. So the x part is over. Let us talk about the y part. What is that? Now dfy and centroid y. Done. So this is the formula in its totality. So np dot square root, this function we are calling and passing on these data. So it will give us some values. These values are nothing but the distance between each data point and this, which we are calling it centroid. And look at this 0. Why 0? Because there is a data point over here, a data point, and this particular star, which we are calling it as centroid, they are sitting at the same location. So what will be the distance between that data point and the centroid? 0. So we are getting 0. Done? Very good. So distance all the distances have been calculated. 25 records. Data points, right? 25 rows are there and each row has got one number. So we are only taking average of X. How we can take average of only Y? Like this. We know how we can take average of the columns, right? What we can do? We will say like this. Put another one, X, then Y. And then what we'll say? Mean. You got it? Yes. 5.76, 5.92. Mind you, this is series. This is not data frame. When you're getting output like this, it is a series, not a data frame. Now, if we want to have data frame out of this, then what we will do? Can we do something like this? Let me put this as X here, not X, sorry. We will call it as average. And just see, we will write average and just see what happens. Good. This looks better. Correct? Now, what we will call this? We can call it as DF average equal to this, and everything is anyway there. So DF average is what? Nothing but the average that we have calculated and put in another data frame. Now we have three data frames, mind you. One is for XY coordinates, the other is about centroid, the third is DF average. What does the task sheet tell us? Find the average of all the data points. Done. Assign the average thus calculated to the centroid. All that we have to do is simple, right? Go here and say centroid is equal to DF average. Before we overwrite centroid, let us hold the value of centroid. That is nothing but the first record, but still we can hold it, right? Let us hold this so that we will make a graph and just analyze it. Centroid, we will say old. That is nothing but this centroid. Okay? Now, let us, with our knowledge of Python, we can check the ID of both of them. This, let me take the ID of centroid also. Both are same. That means same data frame is being referred to with two names, centroid old and centroid. Okay, having done this, what happens? Let us see about centroid now. Centroid ID. This ID and the ID of DF average we will check, right? They should be similar. Yeah. All this number ending with 9376, 9376. And what was centroid before doing this? Centroid's address was 6384. Now it becomes 9376. Meaning my old centroid is being referred to as centroid old, and the new centroid is holding the value of the average that we calculated. Fine. Now we have four data frames. DF XY lying in DF. We have another data frame called now centroid, which is holding the value of DF average. And we have DF average. Now we have centroid old. What we will do with all these things? We'll just see. Now, probably the last point. Draw a scatter plot for the data points as well as the revised centroid. We have already overwritten the old centroid. Now new centroid has got the value which we call it the average of all x's and y's. Correct? Now we will it is telling please draw the scatter plot. Okay, so obediently we will do what we have been asked to do. PLT we have already written, let us copy paste. There is no need to type it again. This is already there, correct? Copy paste here like this. Now what happens? Wow, this star has shifted from this area. Just see this, which means the averages of all the data points, including this data point, is coming at this location. We can say that this location is the center location considering all these data points. Each data point has got its own coordinate. They have been put together. We have taken average and we are defining the center location to be like this. This is nothing. See, we are taking average of x. So average of x probably has come somewhere here. Let us see that. df dot average. So what is the average of x? 5.76. This is nothing but we checked. Again, let us check. So dfx is 5.76. So 5.76 is here. And then another thing is what? NP mean of dfy. That is 5.92. So this is 5.92. So the intersection of 5.76 and 5.92 is nothing but this location. Then this is what the task sheet asks us to do, and we have done that. So why we have done this? Are we achieving any objective? Well, yes and no. We are saying yes because this knowledge will help us to deal with K-means algorithm. That way, yes, that objective has been achieved. But this as such has no value because you know what? This all data points are being considered as one cluster. There was no need to take distance calculation, etc. In the beginning itself, we could have taken the average of x and y and drawn this graph showing this star at the center or as a centroid. That is fine. This was just a practice session, nothing else. In the next video, we will, having understood how scatter plot works, how we can calculate distance, how we can calculate average from a data frame, we will be able to understand K-means algorithm easily, and we will be ready to work on problems where we can implement K-means algorithm. Okay, before we sign off, what we can do is we will put all these commands in one cell. How we can do that? Let us learn that. That is not very relevant, but yes, that is one thing which we should know. So having converted this, let us convert this cell. See, green means it is it's in a command mode. So we have to change the mode by pressing escape. See, the color has changed to blue. Now we can select all the cells that we have worked on. Okay, like this. Done. Now what we can do? Press Shift M. Yeah, this star and this is star. Correct? This is what we have done. We have put everything in one cell. Of course, there are unnecessary things, right? If it is in one cell, it makes no sense. It makes no sense. All these are unnecessary stuff. If they are in separate cell, they will show you the result. Here it makes no impact. Here we checked ID. This is fine. Let us run it again. So this is the end result. Okay, good. Thanks for watching, and let us await the next video on K-means algorithm.